Okay, so now let's say you're going to order a pizza and you get, two toppings on your pizza. Okay, so let's say they have the toppings like pepperoni and sausage and ham and green peppers and onions and black olives. Okay, those are your choices. Okay, so how many different pizzas can you get? That's the question. So, um, and you're only gonna just, you're gonna choose two different toppings, right? Okay. So this is called a combination problem. Think combination pizza. Okay. So, um, you have you could think about your choices, right? Like you have 10 choices for the first one for your first topping, and now you only have 9 choices for the second topping. Okay, so you can make 90 different pizzas. And advertisers will say something like that. Okay, also they choose committees. Sometimes they'll say, okay, let's pick 3 people to be on the committee. Now, and we have 20 people to choose from. Now you might say, well, why isn't this a permutation? Why is it different? Because in this case, order doesn't matter. Okay, it doesn't matter which topping you put on the pizza first, right? So if you say, oh, I want a pepperoni ham pizza, well, that's the same thing as if you said, I want a ham pepperoni pizza. Okay, sorry. Now maybe in your mind it makes a difference which is put on first, the pepperoni or the ham, but it's the same pizza, right? It's both pepperoni ham pizza. I don't think you get to tell them when you order it which one you want put on first. Okay? All right. So these are called combinations. Same thing with the committee. You're going to have people and you have, Adrian and Betty and Charles and David. And you say, hey, we're going to get 2 people to go get the pizzas. Well, somebody says, okay, let's have Adrian and Betty go get the pizzas. Somebody says, well, let's have Betty and Adrian go get the pizzas. Well, the order doesn't matter, right? It's the same choice, okay? All right, so that's what combinations are based on. There are 3 things. First of all, your items have to be from the same group. So remember back in the first video when we were doing license plates, you couldn't, that's not a combination because some are letters and some are numbers, right? Okay, so they're not from the same group. 2, their items don't repeat. Okay, no item is repeated. So, you could say, like in our pizza problem, we're going to have pepperoni and onions. I guess you could say I want double pepperoni. I don't know if that's a thing, but assuming you can't say that, then you got pepperoni and onions. Definitely with the committee, you can't pick the same person twice, right? Okay, so once they're on the committee, okay, so no item is repeated. And then the third thing, and this is usually the big deal, order doesn't matter. That's what makes it a combination and not a permutation. Okay, so there's a lot of discussion sometimes. Is it a permutation or a combination? So to help with that, we're going to decide. We're going to have some examples here. Lots of words, but we're not actually going to solve the problem. We're just going to decide if it's a permutation situation or a combination. We have 6 students, an A here. 6 students are running for student government, president, vice president, and treasurer. The student with the greatest number of votes becomes the president. The second highest vote getter becomes vice president. The student who gets the third largest number of votes will be treasurer. How many different outcomes are possible for these 3 positions? Well, they don't repeat. Like you can't be both the president and the vice president. Okay, so it's true for both permutations and combinations. They're from the same group. Okay, so you've just got 6 students that are running. So they're coming from the same group. That's true for both permutations and combinations. Now, does order matter? Yes, it makes a difference who comes in first because they get to be the president. So this is going to be a permutation. Okay. Now, B, 6 people are on the Board of Supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees could be formed from the 6 people? So it's the same group you're pulling the people from, 6. You're going to pick 3 of them. You can't repeat them. You got to have 3 different people on the committee. They can't be, one person can't be on the committee twice. Does order matter? No, it doesn't. If you pick, person A, B, and C, it's the same as if you picked B, A, and C. So this is a combination. Okay. And the last one, Baskin-Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each of a different flavor. How many bowls are possible? Does it make a difference which ice cream I put in the bowl first? I'm going to say it doesn't make a difference which one I put in the bowl first. So I'm going to say this is a combination. Okay. Now, when you think about that permutation up here on A, you had 6 things to choose from, and you were taking 3 at a time. Okay, so the notation for combination is very similar. You have a C instead of a P, and you're taking N things R at a time. Okay, and but it's a combination, not a permutation. Okay, so the definition is N factorial over N minus R factorial. So it looks like a permutation, right? But I didn't put in the notation here. Combination, N things, R at a time, times R factorial. Now that R factorial is in the denominator. And the reason for that is you have to divide out the repeated combinations because order doesn't matter. So like if ordered mattered, say you're doing pizza toppings, pepperoni and ham, if order mattered, that would be one answer, but ham pepperoni would be a different answer, right? Okay, if order mattered. But if it doesn't matter, these are the same. So that's the difference between a combination and a permutation. Well, this R factorial here, those are that you're dividing out those repeated situations. There's a longer explanation in the textbook if you want to see that. Okay, so we're going to give you some examples in the next video.